Okay, so in this video we're going to revise our differentiation rules. We've got on the left hand side here a bunch of functions, f of x equals ax to the n and so forth, and these are all the rules that you really need to know and revise and in the lead up to your exams. And then the overarching rules over all of them, they govern everything, the chain, product and quotient rules. Now all these ones with these g dash x appearing at the front, that is because I've used the chain rule to provide you these rules in a general form. On a formula sheet for your exam, you're only going to get k cosine x, for example, rather than having a full, and assuming it's linear in there rather than a full function in there. But let's see how they work, because it's all well and good to know the rules, but it's more important to be able to use them. So let's differentiate each of these things. So remembering, of course, that when you do derivative, you have dy dx. Now we've got an exponential. We told an exponentials here, you find the derivative of this, and that goes out the front. That's what the g dash x is telling me. So the derivative of your power is 2, 3e to the 2x, and the derivative of that is just 0. So it gives you 6e to the 2x. Done. Next one. Again, y equals, so dy dx. The 5 stays at the front as it is. And we know sine becomes cosine, and everything inside the cosine remains as it did with the sine. That's what this rule up here is telling us. We have sine, the g of x stays there, the g of x stays there, nothing changes there. All that happens is the g dash comes out the front. Now the derivative of this is a linear equation, which is, if I expand, it gives you this. And the derivative of this linear equation, that's becomes 0, the derivative of that becomes 2. So 2 comes out the front. So you're left with 10 cosine of 2 bracket x plus pi on 3, like that. The next one, we have x and tan x. Now the temptation is just to do derivative of that is 1, derivative of that according to up there is x squared, and you're done. Problem is we have a multiplication between those two, so you cannot do that. Given that there is a multiplication, we must use the product rule. So we're going to call this first one u, this second one v, and go from there. So u is equal to x, therefore u dash is equal to 1. You got v equals tan of x, and according to our rules just up here, that the derivative of tan is sec squared. Remember, sec squared is 1 over cosine squared. Okay, so 1 over cosine squared, or I should write just sec squared of x there. And also the derivative of the x comes at the front, which is just 1 in this case, so it doesn't really do anything. Now, we do v times by u dash, so 1 times tan of x will give you tan of x, plus u times v dash, so you'll end up with that, and let's, I guess, write it in one line. Don't have to rewrite it now, but just given the way I've written it, I'll give it some space. Like that there, so it's product rule. Next one, this one is just a polynomial. This is one of the most simple ones to differentiate. The 3 comes out the front, so 3x squared. 2 comes out the front and multiplies to 6, gives you 12x, and then plus 9 at the end. Remembering x to the power of 1 differentiates and disappears. Next one, we have quotient rule happening because of the division symbol. We can't just do 3x squared over cosine, can't do that. This requires your quotient rule. So let's do u is x cubed, so u dash is 3x squared. V is sine x, so v dash is, we know, cosine of x, and the derivative of the x comes at the front, which in this case is just 1, so it stays as it is. Then we have to look very carefully at the quotient rule. Order is important. It's v times the derivative of u, so the derivative of the top one times the bottom, minus the derivative of the bottom times the top. Okay, so we've got to do v times du first. All right, so v du, so dy dx is equal to v du, so 3x squared sine of x, minus u dv, so minus x cubed over cosine of x, and that is all over sine squared, because that is our v squared. Now that's enough, but you need to leave it like that. But if you want to, you can take common factor out and leave it like this, which if you're asked to solve it would be a handy place to go. But you don't need to. And I always caution you against overworking it. So unless I ask you, I would leave it like that, less working to do. All right, next one. Once again, we've got a multiplication between the two. So we're going to have to use our product rule. Okay, there's our u, there's our v. So u is x, so the derivative of x is 1. V is cosine of pi x. The derivative of cosine becomes sine with pi x in there, but don't forget it must be a negative sign. And the derivative of pi x will come out the front, which is just pi. And now we do v times du, so dy dx equals v times du, so 1 times cosine pi x, whoops, plus u times dv, which is that. And then we simplify it, of course. 1 times cosine pi x is just cosine pi x. And then we have minus pi x sine pi x there. Last 4 we're down to. Okay, 5 root 2 minus x. The first thing I'm going to do is write it as 5 2 minus x to the power of a half. Becomes a lot easier. And then I can do my derivative using the polynomial rule. So the half comes out the front. So times by a half. 2 minus x, take away 1/2, makes it negative half. But the other thing that happens, because we're kind of dealing with a chain rule here, it's not just the 1/2 that comes out the front. This 1/2 does come out the front, yes, but also the derivative of inside there. So it's -1 comes out the front too. And you end up with -5 over 2, 2 minus x to the power of -1/2, which I then can write as over 2 bracket 2 take x to a, oops, to the half, which is the same as a root. Now this one you can use the chain rule from if you really want to. I will use the chain rule for this other one here because these two are the same thing, except they had a power of a half and this is a power of 5. So I'm going to actually use the chain rule in this case rather than doing a shortcut. So I'm going to let u equal 3x squared minus x. So the derivative then is 6x minus 1. Y is u to the 5. So the derivative of y dash is 5 u to the 4. Therefore, the derivative is these two multiplied, because that's what the chain rule tells us, remember? The chain rule tells us we multiply the two individual derivatives together. So we end up with 6x minus 1, please do not forget brackets, there are 2 terms there, times 5 u to the 4. That 5 can come at the front because that's just multiplication. 6x minus 1, and then 3x squared minus x to the power of 4. Now I could have done that from the start. I could have just said, oh, the 5 comes out the front, the power goes to 4. That's what that is, and that's what that is. And then the derivative of 3x squared minus x comes out the front too, and that's what we've got. So you could have shortcutted it if you want to. Now notice there's a factor of x in this one. Because of the power of 4, just leave it. But sometimes if you had like a power of 2, you can actually remove that x from here as well and come out the front. And it'll be, you got to think of it in terms of x bracket 3x take 1, but they're both to a power of 4. So that'll be x to the power of 4, 3x minus 1 to the power of 4 if they're going to ask you to do that, which would then become 5x to the 4, 6x minus 1, 3x squared minus x to the power of 4. But again, don't overwork it. Unless I ask you to do so, I would stop there. All right, last 2. Derivative of this one. Well, first thing I remember is this is the same. This one here is the same thing as 4 bracket x plus 1 to the -1. So the derivative of 2 is 0. That goes. You've got this negative sitting here. Now, that -1 comes out the front. So -1 times by this -1, this -1 here. This other -1 comes from here. Bracket x plus 1. And you subtract the power by 1. And whoops, I forgot the 4. negative 1 comes at the front, times the 4 that is already there, x plus 1 to the power of negative 2. Negative times a negative is a positive, so you get 4x plus 1 to the negative 2, which simplifies to that. And last one, logarithms. Our rule at the top tells us you find the derivative of the piece inside and you divide that by the piece inside. Let's do that here. The derivative of 3x squared minus 2x is 6x minus 2. Then you divide that by the bit that was in there already. And you're done. That's as far as you need to go with the log. And the derivative of the bit inside, 6x minus 2, and divide it by what was in there already. You could use the chain rule, but if you know the shortcut rule, much quicker and easier. And that is a brief revision of how to differentiate functions using product, quotient, chain, and all our standard rules for functions.